Zoom and Pan. Basically, what this filter does, which is super useful for a lot of things, is combine two actions. The first one is it scales your entire video by a zoom factor. Let's say our zoom factor is 2. That means that each pixel will become a 2 by 2 pixels square. And the second action is that it crops into a part of that scaled video so that you have your original video dimensions. And that's the Pan part. So in this example, what you have is a full HD video. And your zoom factor, as you said, is 2. That means you're taking a quarter of the image, a 960 by 540 rectangle. Always the same aspect ratio as the original. And we scale it to become our new full HD video back into 1920 by 1080. And you can see I also illustrated in X and Y, and these are the Pan values. The values for them are pixels in the original frame from the top left corner. The way I like to think about it is like we're moving our top left corner. That's how we pan. And as always, I'm also linking you to the official documentation and the source code because I think it's very good that you're curious. This is one of those filters where I think it's a lot easier to just start with examples instead of going through the possible parameters. So to start us off, this is the most basic example I could come up with. We're only zooming in without panning at all, meaning we're defaulting our pan to the top left corner. The Z option is how we pass our zoom value, which as we said is 2, okay? But I wanted you to see the effect. I wanted to see that this works per frame. It didn't just pop into the final result. So we're zooming in gradually by 0.015. The way this works is that P-zoom, previous zoom, is the value for the last calculated zoom in the previous output frame. When there isn't such a value, it defaults to 1, which means no zoom at all. And the minimum function is how we cap it at 2. So this is an addition, means that each result would keep on increasing and increasing and increasing. Okay, so the first frame will have a Z value of 1.015, the second will have a 1.03, and so on until we reach a value of 2. That's where we cap it, because when this left-hand side increases past 2, the minimum function would pick the right-hand side instead. That's how we cap. And next up, we have the D option. D for duration. It's a bit weird. We can output more frames than we received. And that's actually the default behavior, a value of 90, 90. I don't know who had this crazy idea that this would be the default, because to this very day, I never used any value other than 1. Maybe you will have use for that. And the next option is FPS, the output frame rate. If you have a D option, I think it makes sense to have this value along. But I usually just want to retain the original frame rate and have a D value of 1. I'd have expected this would be the default, that if I'm not passing an FPS argument, I'll just retain my original frame rate. But it's actually a constant value of 25. Go figure. Okay, so next up, we're still keeping it quite simple, but now we're adding some panning. What we're trying to do here is to retain our center. And the way we're doing that is we're using the calculated zoom as part of our expression for X and Y, the pan values. IW input width, IH input height, meaning the original dimensions, okay? When we divide them by 2, we get the center, but we're describing our top left corner. If this is our top left corner, this would be a rectangle. Not good, not what we want. So we have to deduct half of our zoomed in rectangle, okay? I know high school geometry is very much past you, so I have this illustration. We are now, for the sake of explanation, assuming a simple 200 by 100 rectangle and a final zoom value of 4. So you can see that the final rectangle would be 50 by 25, And the midpoint at 2x zoom would have a 100 by 50 rectangle. And now we use our equation in each frame, and we'll see that this part will always result in 100 because it's always the input, okay? That's where the deducting from, okay? And on the first frame, this will result in a 0, meaning that we're still retaining our top left corner without moving at all. And on the mid frame, we're deducting 50, meaning that our result will be 50. So we'd have 50 on this side, 50 plus 100. What we are left on the right-hand side is 50. So we're centered. And on the last frame, we're resulting in 25, meaning that we're left with 75. So 75 on this side, 75 on this side, 50. We're still centered. So the more you're zoomed in, the less you're deducting, so you have a bigger gap. Okay, let's move on.